So intense. For today, you need 4 maybe.
I know. Oh my god. Wait, is it okay or is it like an intense?
Sure. They're going to be hard to graph like that, but that's okay. So polar graphing is a brand new concept for you. Stop. This is totally brand new, so you need to like zone in. I don't think you've probably ever polar graphed with a radius and a theta. No. Okay, cool. So this is how you make, polar graphing is how you make really cool like spirals. It's how pineapples can be formed with polar graphs. It's pretty cool. Most of nature can be graphed mathematically. Most of nature can be graphed mathematically. Pine cones. Those are the only ones I can think of off the top of my head.
Could a tree, like the rings of a tree?
Yes. Well, sometimes the ring of a tree are just like
Circles.
yeah, to form circles. Polar is radiance. It's just another form. It's just another method of not graphing, indicating a degree measure. Degrees, radians, they're essentially the same thing. They're just units of measure, right? So we have So we have yards, which can be broken down into feet. We have feet, which can be broken down into inches. They're just another way to look at. Can't think of the right word. Graphing, I guess. Yeah, Josh.
Is there enough room on this page to take?
Maybe depends on how big you write. If it were me, I would do my notes like I normally do, and every time I do a polar graph, I would leave space, and then at home, I would cut it out and put it in my notebook. That's what I would do. Okay, so. X, Y in rectangular form. That's what it's called. When you graph on a Cartesian plane, when you learn how to graph and plot points, and it makes the apple, and you connect the dots, and you get the fun picture. What is that? 4th grade, 3rd grade. Remember when you used to do that? The dots to dots, and you would plot points, and it always makes some kind of fun shape. Okay, so we're going to make fun shapes. Our theta is R is the radius. If you look, right, these polar graphs, they have circles. So there's a radius associated with the circle. And then theta is the angle measure. I'm pretty certain that you're always going to be in radians. Yeah.
Are there any correspondences between X and Y and R?
Yeah. X. Well, sure. X is the no. No. So let's just start by plotting some points. If you printed the polar graphs that I gave you, there's some extra lines. So what you really need to know are 30, 45, and 60. We're going to start in degrees, and then we'll move into radians. So I would each line is 10 degrees. So 30 is here. 45 is between 40 and 50. 10, 20, 30, 40, 60. Probably find, I'm sure there are polar graphs out there, or polar grids that go by tens, or that just go by 30, 45, 60. I'm sure you can find those, but I want us to practice using increments, not 30, 45, 60. Okay, each circle represents a radius of 1. So the first circle, the radius is 1. The 4th circle, which is hard for me. I can't even trace a circle correctly. It is really hard being me. Look at that, I can't even trace the darn thing right. The 4th ring, the radius is for, etc. Okay? So far, so good?
No.
So let's just plot some things. Let's just plot some points. So and I'm going to do several on one grid. I don't want to do 1 point per grid, otherwise you'll use like 20 in one class period. So let's plot the point 3, 90 degrees.
Oh.
Okay, so even though it's r theta, start with theta first. Start with theta first. So if those circles weren't there, where would 90 degrees be?
Top.
Top. Okay, so there's my angle. And now, what's my radius?
3.
The radius I gave you is 3. Okay, so 90 degrees. I'm going to erase this point. 90 degrees is, once again, drawn terribly, but 90 degrees. Every circle on that line is 90 degrees. So 3. So from the origin, I'm going to go to the third circle. 1, 2, 3.
Well, check
Okay. And I'm going to label them. So this is going to be point A. Rue?
Is it true that R is 1 for every circle on every polar graph?
Yes.
Okay.
Unless you're told otherwise. So Rue's question was, is R 1 for every circle and every polar graph? Yes. But you can change the increments, right? Just like you change the increments of X and Y. I have never seen anything other than increments of 1 for the circles. Yeah.
Is it called a polar graph? Because it looks like you're looking down on the curve.
No idea.
Wait, what? A polar graph?
A polar graph. Josh wants to know if it's called a polar graph because it's like you're looking. I don't think so.
I think it's a Josh.
You can look it up. Okay. Let's graph another point. Let's graph 1. Let's do it in radians. How about 3 pi over 4? Find the angle measure first. Find the angle measure first. Why? I'll explain to you when we start doing negative radii and we'll start doing negative. So negative 3 pi over 4 is in, positive 3 pi over 4 is in the second quadrant. Yes? Okay, so find it. It's going to kind of be floating in between two, what do you call it? Two grid marks. I don't know how else to explain it. Where's 3 pi over 4? So second quadrant. And then I'm going to do a radius of 1. So show your neighbor where you put it. 3 pi over 4. So this is 80, 70, 60. Ish. I might be off a little bit, but ish. I might be off by 1 spoke. That's a good word, like spokes of a wheel. I might be off by 1. So that's B. Okay, we are going to do a couple more, and I promise it's going somewhere. So how about we do 11 pi over 6. Okay, so plot that one. Show your neighbor. Quadrant 4. 11 pi over 6. What, 330? 330? So 11 pi over 6. 360. 350, 30. Oh, it's on the very outer run. Correct? Did I do that right?
distance in between points on color graphs.
Don't think so. Where's negative 2, 4? Like, sorry, like 4th grade. Where's negative 2, 4? Quadrant 2? Yes? 1, 2, 1, 2, 3, 4, boom. There it is. Agreed?
Yes.
There is 1 point. It's negative 2, 4. It lies in the second quadrant, and that is it. Agreed? Okay, polar graphs, that's not true. With polar graphs, that is not true. I want you to find 5 negative pi over 6. Eileen?
Do the same thing.
Yeah, it's the same as point C. 5, 11 pi over 6, and 5, negative pi over 6 are the same point. Do you remember what you call angles 11 pi over 6 and negative pi over 6, their relationship? They're coterminal. Yeah, those are called coterminal angles. So this is the same point as angle, as point D. So on a rectangular system, that's it. Negative 2, 4, that's it. There is no other point that will take you to negative 2, 4. In polar, 2 points take you to 5, 11 pi over 6. There are 2 more. Well, actually, there's an infinite number of more, but from 0 to 2 pi, there are 2 more. Why don't you start a new graph? Well, it's up to you. I would start a new graph because it's going to start to get involved. So if it were me, I would start fresh. You can have negative. You can have negatives. So see how we had a negative angle? You can have a negative radius. Is the radius negative? No, it's about direction that you're moving. So let's look at something like negative 2. How about, we haven't done a third quadrant. 5 pi over 4?
Yeah. That A.
Sure. Okay. Always start with the angle first. Always start with the angle first. Where is 5 pi over 4? Third quadrant. Okay, so I'm gonna, like, you know, that little dotted thing. Where is it? 180, 190, 200. That's 5 pi over 4. Every circle has an angle of 5 pi over 4. The difference is the radius. So here would be a radius of 1. This would be a radius of 3, 4, 5, etc. But it's negative. So instead of, from the origin, instead of going toward 5 pi over 4, you're going to move in the opposite direction. And you're going to go to the other way. Oh my gosh. Here, maybe. Does that look about right? It's hard to do the 45 increments.
Yes.
All right. Let's try. Negative 3. That's 120. 2 pi over 3. That's 120, right?
Yeah.
I think so.
Let's find 2 pi over 3. What quadrant is 2 pi over 3?
Second.
It's not going to end up in the second. You start in the second quadrant.
And
You're going to end up in the
Fourth.
fourth quadrant. You're going to end up in the fourth quadrant. So 120. Anthony says it's 120, so if that's not right, it's his fault. 90, 190, 110. I think it's, am I too high? I think it should be lower, yes?
No.
I think it should be lower.
What's the
360, 350. How about there? Better?
Yeah.
Okay, so. -5. 5, -6. 5, positive 5 pi over 6. Where should you start? 5 pi over 6. The radius is -5. So when you find 5 pi over 6, which is in the second quadrant, instead of moving toward the positive angle, you're moving away because it's negative. Moving the opposite direction of positive 5 pi over 6. So essentially you're moving to where? Where's 5 pi over 6? 5 pi over 6, where is it? Second quadrant. And it is 1, 2, 3. That's 5 pi over 6. So where is -5? -5 pi over 6. Fourth quadrant, where? Anthony?
Where point C was.
Where point C was, and point D. And now, well, the second point C. So this is -5 pi over 6. 1, 2, 3. It's like here. Yes? Is that not the same exact spot as 5, 11 pi over 6? 5, -pi over 6?
Yeah.
So 5, 11 pi over 6 is the same as 5, -pi over 6 is the same as, what did I just give you? -5. Uh-huh.
Would you ever use anything like 1/2, comma like 5 pi over 6?
Sure. Sometimes that happens in real life. Not everything is just these nice numbers. How do you graph that? You plot the radius in between 1 and 2. Here, the radius is greater than 0. The radius is greater than 0. The radius is less than 0. Every point can be written 4 ways. And then, of course, infinite around. Here, theta is greater than or equal to 0, less than 2 pi. Pardon me? I haven't gotten there yet. You're going to figure it out. The next point I gave you, radius was greater than 0, but theta was less than or equal to 0, greater than -2 pi. Sorry, I didn't leave enough room. The angle is between 0 and -2 pi. This one, the radius is less than 0, but the angle is less than 2 pi, but greater than or equal to 0. Positive radius, positive angle. Positive radius, negative angle. Negative angle, positive radius. What's left?
-5, -7 pi.
So I need a negative radius. I'm sorry, what's the angle?
-7 pi.
No. I want to know the domain and range. -2 pi, less than theta, less than or equal to 0. Figure out where it is. Like quiz, test, final exam, whatever. Like these are the restrictions that will be given to you, and you need to be able to figure out what's the radius, What's the angle measure? So if the radius is less than 0, it automatically has to be -5. Agreed? Automatically has to be -5. Negative. That means that rather than going towards the positive angle, you're going in the opposite direction. Figure it out. Being able to plot the points is the first step in being able to draw the graphs. Plotting the points is the first step of being able to draw the graphs. 4 ways to get to everything. Help each other out. Oh. Do you need help? What'd you get?
So you're trying to get
-7 over 6.
No, it's the more, it goes past the, it's like where 5 pi over 6 would be.
Yeah, -7 pi over 6. And then you did a negative angle. No, you can't. You do a distance function. Probably.
because these two.
The diagonal.
Not true at all. I know very little about mathematics. What do we got? It has to be -5 because I started you that way. Where are you going?
-7.
When you're doing a negative radius, let me redraw this. If I want to end up, let's say, in quadrant 2, okay? That's where I want to end up. With a negative radius, where does the angle need to start? 3rd quadrant. Yeah, whatever it is. So if this is some r, some theta, to get back here, this needs to be -r with a theta. Okay? Oh, no, not -r, theta, -r.
180 minus.
Yeah, 180 minus theta. 2 pi minus theta.
Wait, is it like theta plus?
Well, it could be theta. It depends if you're doing theta, which quadrant you're in.
Oh.
Okay, so I'm going to give you 1 point, and you're going to find all the possibilities. Okay. So let's say you are given -3 5 pi over 4. I want you to find angles and radii that take you to -3 5 pi over 4, given the radius is less than 0 and -2 pi is less than or equal to theta is less than 0. I want you to find radius is greater than 0, -2 pi less than theta less than 0. And I want you to find radius greater than 0, theta between 0 and 2 pi. Those are your 4 restrictions. Negative theta, negative angle. Sorry, negative radius, negative angle. Positive radius, negative angle, positive angle. Work together, figure it out.
Was the easiest to track with that? it would be that would be first one.
If you're stuck, help each other. Talk through it. Where's the given point? Which quadrant? First quadrant. So 5 pi over 4, I don't know, it's like here somewhere. Yeah, I don't want to count. And then negative 3. 1, 2, 3. Ish. Okay, how am I going to get there with a negative radius and a negative angle? How am I going to get there with a negative radius and a negative angle? Where do I need to start if I'm going to have a negative radius and I want to get to quadrant 1? I need to start in quadrant 3. A negative radius is going to move me back to quadrant 1. Okay, then I want a negative angle, which goes this way. So how am I going to get to 5 pi, or how am I going to get to, this essentially is pi over 4. What do I need to do? Negative angle goes down. Which is what? Negative 3 pi over 4? Yeah? All right, positive radius, negative angle. Positive radius means I want to go towards with a negative angle. What's that?
3 negative 7.
Give me an actual angle. If I want a positive radius, that means I'm going here, but I need a negative angle. So what's the negative angle that takes me to negative 7 pi over 4? Sorry, I misheard you. It's not what you said. You said 3 pi over 4 minus blah blah pi over 4.
No, I said 3 comma negative. Sorry.
I misunderstood. We're good. 3 positive radius pi over 4. Yes?
Yes.
Okay. If I took off the circles, I should have told you to take off. If I took off the circles, this is a rectangular point, right? It's 2, 4, or it's 2, 16, or whatever it is. But this point floating here, if I took off the circles and I just did a regular rectangular grid, maybe it's 2, 4, maybe it's 2, 3. We can convert from polar rectangular and rectangular to polar. Okay, so polar is an x and y. vice versa. Polar rectangular, essentially that means r theta converting to an xy. Rectangular to polar, of course, is the opposite way. Yeah,
If you convert polar to rectangular, like a bunch of points, will they all like be arranged?
Yep. We are going to make flowers, and we're gonna do all kinds of stuff. Okay, polar rectangular. Let me do a different color so it looks pretty. Think about your unit circle. Think about your unit circle, and you have some point x, y. Okay, in terms of sine, cosine, tangent, etc., what does x represent? Cosine. And what does y represent?
Sine.
Okay, so x is going to be r, because you have a radius now, times the cosine of theta. And y is r times the sine of theta. So x is cosine, y is sine. We'll do some and it'll be like, oh, okay. Polar is rectangular. What's the equation of a circle? X squared plus y squared equals r squared. You're going to know an x and a y. You can plug in for x and y, get an r. But I also need to find an angle. Right? If I'm going to have r, great, here's how I find r. But how am I going to find theta? So it would be helpful we use some inverse functions. You have to know your tangents. The tangent of theta is y over x. Yeah, Rue.
Wait, so if we're using the circle equation, does that make the xy point the center of the circle?
Nope. The center of the circle there is at the origin. X minus h squared plus y minus k squared equals r squared. The center is at hk. This has a center at the origin. Yeah? Okay, so let me give you some coordinates. Let's figure out some points. Oh, I just did that. Okay, so we're going to convert. We're going to convert. Make it nice one. Yeah.
So isn't cosine only x on the unit circle?
Right, but we're putting them together. We're taking the rectangular with the unit circle and we're putting them together.
Yeah, but like on the polar graphs, the radius isn't always 1. So how can we put that?
Oh, we'll figure that out. You're right. On the polar graph, the radius is not always 1. We'll figure that out. All right, so if you have 3 negative root 3, I'm going to convert that to polar. So this is my x. This is my y. Agreed? Plug in. R squared equals 3 squared plus negative root 3 squared. 2 root 3? 2 root 3? And where's my tangent? What's my angle? The tangent of theta equals y over x.
5 or 6.
I hear pi over 6. I hear 2 pi over 3. What do we got? It's got to be negative, or it's negative, so it has to be in quadrant 2 or 4. We'll figure that out in a minute. What angle? 60 degrees. Quadrant 2. 2 pi over 3. 2 pi over 3. You have to know your tangents. Okay, so here's the problem. The radius is 2 root 3, and the angle is 2 pi over 3. Correct?
Yeah.
Okay. In the regular Cartesian plane, the regular xy, where is 3? Hold on. Where is 3 negative root 3? 3 negative root 3 is in the 4th quadrant somewhere. Yes? The conversion we got, 2 root 3 to pi over 3, that's not in the 2nd quadrant. If you draw it on your on your polar graph, where is 2 root 3 to pi over 3? Second.
No.
Yeah, this is the 2nd quadrant.
Yeah.
But the point that you're given, hold on, rectangular can only be one place. It can only be one place. This is quadrant 4. When you did polar, you got quadrant 2, correct? It needs to be in quadrant 4. So remember, tangent can be negative in either quadrant 2 or 4. You have to check. So instead of being, this is not right, this is in quadrant 2, you were given quadrant 4.
So it's negative 5.
So there's a couple ways you can write it. You can write it with a positive angle instead of 2 root 3. If you write it as a positive angle, what is it? It has to be over 3. You're not changing the reference. I want to move to quadrant 4. It's a 60-degree reference angle. How about 5 pi over 3? Now I want a positive angle. There are 4 answers. I want a positive response to this one. 5 pi over 3.
So would you tell us that you want a positive thing?
No, you need to figure it out. Oh, yes.
Because technically,
I will give you an option.
Wouldn't you like notes 5 pi over 3 off the bat because the y is negative?
Some people can't visualize that.
Okay. I feel like if the y is negative, that means
Correct. It has to be quadrant 4. Yeah, Linda.
Can you walk through how you got to tan theta? I mean theta equals 2 pi over 3.
Got to know your unit circle. So tangent is negative root 3 over 3.
Isn't it the same as 1 over root 3? Or negative 1 over root 3? It's 1/2 over root 3.
But if it's 2 pi over 3, wouldn't it be root 3 over 2 over 1/2?
Yeah, exactly.
Okay, there's a question that this might be the wrong angle. Negative root 3 over 3 is 1/2 over, which is pi over 6. It should be pi over 6. It should be pi over 6, which is,
Negative pi over 6.
pi over 6. This should be 5 pi over 6. Yes? Yeah. No, Glenda's right. Yeah.
How do you know whether x or y is negative?
Okay, so that's the question. Y is negative. You were given that y is negative. So you don't need, hold on. So when you're looking at what quadrant it's in, so this is what Anthony was asking. Here, x is positive, y is negative. Agreed? You were given x is positive, y is negative. It has to be a quadrant 4 answer. You were given that X is positive, Y is negative. That is quadrant 4. So, oh, these should be over 6. 5 pi over 6. So therefore, this is 11 pi over 6, yeah? 11 pi over 6. Yeah, I'm changing them because it was the wrong reference angle. It was supposed to be 30 degrees, not 60 degrees, and I wrote 60 degrees, so that's where the mistake comes in. Josh?
R is the radius, so how do you find out? How did you get from R to tangent?
Because one of them tells you R, one of them tells you beta.
Oh, it was just a different.
Yeah,
Oh, okay.
different setup. Yeah, it should be.
So, is there a reason why we can't use the other, like, why we can't use like the 2 or 3 from the 5 pi over 6 instead of 2 or 3?
Is there a reason why you can't use?
Like negative.
Well, that's why I was saying it could be either way, and so I was getting there that you have to be careful that it's not in quadrant 2.
So, but
If you recognize from the beginning that X is positive and Y is negative, then you know right away it's quadrant. There's 2 places where it's negative, tangent's negative. It's negative in quadrant 2 and quadrant 4. If you recognize right here that this is a quadrant 4 given point, then you go right to quadrant 4. If you're not sure, then you need to check where it is rectangularly. Yes?
if in this scenario, since the radius is not 1, how come the tangent theta of y over x gives us theta?
Because the radius doesn't have anything to do with finding the tangent.
Isn't that y over x assuming that y and x are just over 1, but the hypotenuse isn't 1?
Just, like, they'll be over the same thing anyways. Like, no matter what the radius is, it'll be like
Okay.
y over 3 over x over 3, it's the same thing as y over x.
Okay, so, couple things. The homework, it's due Monday, but if you already wrote it down, I'm going to modify it because we didn't get to equations. We only got to basic plotting of points. So, if you already wrote it down, you should change it. I am going to update it on Aries. I will update it on Aries, but it's a lot of where, classroom, yeah. Not Aries, I can't update it on Aries. So, if you wrote it down, I'm changing it. I will update it on the classroom. I'm going to get it wrong if I do. I'll put it on classroom because I can't think of the problem, the every other odds off the top of my head right now. Your homework. So if you want your homework back so that you can review for the quiz, there's still 2 minutes left in the period. I will give it to you.
Oh my god.
Because that is more than we're after.